So once again, in diagrams, associations between classes appear as single line connections like this. So they can be named, they can use multiplicity specifiers. But in real code, these associations normally look like this. In Java, we have a class name controller, and it has some sort of access to an interface object. Right, so here we would have then controller displayed as a box, and this interface also as another box. Okay, so apparently this is like a user interface object. So here in this situation, this is our controller and this is our interface classes, and we would just have this type of association between them. But this is how it looks like in the code. Basically, inside the controller, there is a member of which is clearly a reference to an object of type interface. If this is just access, we can say controller has access to an interface. We can also provide a directional arrow. That would indicate that interface does not have access to the controller, but the controller has access to the interface, and typically is done through this. In C++ example, very often this could be done through a pointer. A pointer in C++, of course, requires this extra asterisk right here. But the idea is very much the same. Basically, you use the type, and here automatically all objects are accessed by references in Java. In C++, we have a variety of ways to organize structure of our object, but something like this would typically look like this in the code. Aggregation and composition. All right, so composition, the situation with composition is when we have an object in memory, right, that is just occupying physical memory like this, and it physically contains a copy of another object in its own memory. So this is composition. So that this outer box is composed of things and including a copy of another inner part. So this is a true composition. Okay, now association, of course, is different. In association, the instances do not share memory. We have a couple of instances of objects, different types, and one of the objects has a reference to another. Okay, so that's what we have in memory. Basically, this object has memory address, and this object has a variable that captures the address of this object in memory. Therefore, we have this logical connection. So this is an idea of association. So this is composition right here. This is just a plain vanilla association right here. And aggregation is basically the same. Essentially, it's a trade-off between the two. So as aggregation is like a trade-off between association, like this, and composition. So, for example, with aggregation, what we indicate is that we would like to make it so that ticket sale has to have a reservation. Okay, so we want to require that ticket sale must have a reservation present. And typically, so something like this, we say that essentially reservation is essential part of the construction of the ticket sale. So this could be indicated with a diamond like this, right? Just a diamond symbol present in this association, and this indicates aggregation. However, aggregation does not require that reservation is physically put together inside the ticket sale memory. Okay, so these two objects still exist as separate boxes, right? Separate objects. This is the reservation. This is the ticket sale. However, if we have this association, it's very likely that creation of both objects is happening at the same time. Okay, so that's an idea of this type of relationship aggregation. So both aggregation and composition represent part whole, right? Or element collection or component and container type of relationships. In composition, the component object can be only part of the container object, just like we were showing earlier that the one box physically contains in its memory another box. So this physical containment is composition, okay? And aggregation is just a stronger type of association. If we use composition in UML, this diamond shape on the whole part side of things typically is drawn as filled, okay? So you just fill it with ink like this, okay? So this is composition. If it's not filled as it was before, then it's an aggregation. So both aggregation and composition suggest that if something is made out of parts, it's very likely that that whole thing is constructed at the same time when the parts are also constructed. So the life cycle, the life cycles of the whole and parts probably very much similar.